Hi everyone, I'm Ray, and welcome to my talk. I'm just going to start by saying a little bit about myself. My name is Ray, as you can see. I work with CCAN, Symfony, that's a PHP framework, and Django. Here's my Twitter handle, and it's also on all of the slides, just in case you forget and want to tweet about me. I'm originally from the UK, but I work in Zurich for a company called Leap, web development agency. And my pronouns in English are they, their, and them, so anything non-gendered. And if anyone can tell me what the personal non-gendered pronouns for someone in Italian are, please grab me afterwards, because I always like to learn new ones. This is probably the most important slide of my whole talk, because as you can see from the little flags there, I speak English, I speak okay German, and I'm learning Spanish and Swedish on Duolingo. None of these languages are involved in my talk. So if there's any horrible mistakes up here when we get to Turkish or Korean or whatever, that's entirely down to me and not actually speaking the languages I'm telling you about. But we're mostly not going to be speaking about the languages themselves, but about how you write them. And all the different ways. So to start off with, who here is already using Python 3? Cool, there's a lot of hands. Who is not using it yet, but you plan to switch soon? Awesome, you should do it. I hope to give you more reasons why. Python 3 is great. I love Python 3. And one of the big reasons for me that I love it is because we have Unicode by default on strings. It used to be that strings were ASCII by default, and you had to mark them with a little U when you wanted to put in some Unicode. And that works great for someone like me who started learning to program when they were in an English-speaking country and just used 26 characters and some numbers and sometimes punctuation. But that was great when I was just kind of a hobby programmer making Dungeons and Dragons in the command line, you know, in England. Then I moved to Switzerland, and a little while after that I got my first programming job. And that was doing data input and web scraping, basically, of Swiss real estate websites. And all of a sudden, I kept seeing this horrible error come up in the console. What the hell is that? Like, I get the text from the website, I put it in, everything blows up. Because I was in Zurich and looking at city names like Genève and other places that use special characters. Special characters. Sorry? No, this is in Python 2. This was back when I was using Python 2. It was a few years ago. Thank you. And yeah. Once you get past 26 characters, numbers, and punctuation, things just kind of don't really work. And now in Python 3, this doesn't happen. So if I could go back in time 5 years, I would say just start right. Didn't get that chance. But it's okay, I got to learn about Unicode. But what I didn't realize, even back then, was there's more to Unicode than just umlauts and accents like you get in French. There are so many different language systems and writing systems all over the world, and they all grew up kind of independently from one another. They have different traditions and different characters. And localization is way more complicated than what I used to think. So I didn't plan it this way, but I realized when I gave this talk the first time that we kind of move eastwards across the globe. We start out with me in Zurich trying to figure out umlauts, and now we're going to Turkey. And this is where we first see the real damaging effects of bad localization. You see, in Turkey, in the Turkish language, they have 4 different kinds of the letter I. They have the dotless I, which has a small and a big version, and they have the dotted I, small and a big version. And the sad story that brought this to my attention the first time was the story of Ramazan Çalçaban and his ex-wife, Emine Çalçaban. Both of these people, I'm very sorry to say, are dead. And they're dead because of bad localization. You see, this was a young couple who had been married and then broken up, but they were still fighting over text message. And one day, Ramazan sent his ex-wife, hello? Okay, I'm on. Sent his ex-wife a message where he intended to tell her in Turkish, you always change what you're saying whenever you run out of arguments. Typical thing you might say to your partner who you're fighting with. Unfortunately, his telephone operating system had the dotless I. Hers didn't. And so it got translated in her phone to a dotted I. And the end result of what he was trying to tell her came out rather obscene. I'm not going to say it here. You can look it up at the address. And she got angry that he would say such a thing to her. She showed her parents. They all got angry. They invited him over. They stabbed him. He fought back, stabbed her. And the ambulances that were called to the scene got stuck in traffic, and now they're both dead because of a missing dot on an I. I don't think their phone operating systems were using Python, but we still need to prevent this kind of horrible bloodshed in our code. So, yeah, this is just to reiterate what I told you. There's a page here with more details, and I'm going to put all of these slides up at the end and tweet the link, so you don't have to kind of start scribbling down all of my URLs. There are 4 letters for I in the Turkish language, and they each have their own Unicode code point. And so you would think, okay, Python 3 has Unicode per default. If I want to use these in my code and kind of switch between lowercase and uppercase, it will just take care of that for me. And just to test this, in my command line, I set my locale to Turkish, UTF-8, and I have an array of different Turkish letters. And then, I hope you can see this, I hope it's big enough. Then basically, we're going to print them all uppercase and print them all lowercase. And what I should expect to see when I make them all uppercase is 2 dotless I's and 2 dotted I's. And one of my dots has fallen off. And then if I make them lowercase again, I should see 2 dotless I's, 2 dotted I's, and I've suddenly sprung this extra dot from somewhere. Python and lots of other languages just can't do this. It gets confused because, you know, if you only have 2 I's, then you have 1 dotted, 1 dotless, and yeah, it should be obvious, but it's not. I looked around and I found a good solution which is difficult and a bad solution which is easy to fix this. The good solution is to use PyICU, which is the Python extension wrapping the international components for Unicode C++ library. This is a great solution because it has everything in it that you could ever use for Unicode localization. The only problem is it's really heavy. You have to import this huge library, well, this huge library and the wrapper. And if you're just making a little script, then you may feel that's not really worth it, or something you want to package and send on. So the stupid but easy solution is to make a table and just use that when you're doing translations. Use string.translate. Okay, so much for Turkey. I promise. You may be happy or disappointed to know this. I promise there are no more deaths in the rest of my talk. We're going a bit further east, I think that's right, yeah, further east, to Israel and right-to-left writing systems. Possibly one of the first writing systems that comes up in your mind if you think about, well, if you think about right-to-left or if you think about localization difficulties. We have Hebrew, it's obviously right-to-left, English is left-to-right. And you can see, I really like this example because you can see the same text written in 2 different lines, and it's obvious that they go in different directions. And here we get to another wrinkle, because Unicode has this concept called logical ordering, where basically it wants to handle characters, or it wants you to kind of pass through characters in your code in the logical order, not in the way they're displayed. So if I just go back here, if I wanted to put this in my, if I wanted to handle this text in a program, first I would, so I think it says Simtat Aleph Batzlut. Anyone who speaks Hebrew is probably cringing at my pronunciation. But first I would put in the Hebrew letters, Simtat Aleph Batzlut, and then I would put in the Roman characters, Simtat Aleph Batzlut. And then I want to output them in a completely strange direction. Well, in a different direction. I mean, it makes sense. It's logical to put things in the logical order. But what this means is we need bidirectional or BID support. And luckily, there is actually a really nice, simple answer to this. There is a library called Python BID. I think, I'm now not entirely sure, and I can't see my notes because I haven't got the double screen thing going on. I think this was actually developed by a group of Israeli programmers. Obviously, it's relevant to them. And it's open source, because Python and open source are great. And you just pip install Python BID, and it has nice documentation as well. You get display. I'm inputting here my Hebrew string, and that's in the logical order, like the way your brain processes it or a computer processes it. And then I can just get the display form of that with BID. And yeah, as you can see, they are reversed, and one is a lot easier to read for someone who speaks Hebrew. Awesome, so we can do right to left writing. So I can skip through my next couple of slides and we can all go to a coffee break, or not. Because as we carry on in our journey, we next come to Arabic. Arabic is also a right to left language, and it's also quite a popular language, so we should be able to handle it in our code when we're doing localization. And it has this extra wrinkle that the Arabic letters have contextual forms. Their shape changes depending on where they are in the letter, in the word. And this is just kind of a clip I got of a chart on Wikipedia showing you some of the examples. And you can see, for someone who doesn't speak a language with contextual forms, they're completely different. How would you even recognize? And there are quite complex rules, actually. Well, I find them complex because I don't write this language, how the shapes change. And this is actually, it's one of these things, once you notice it, you can't not notice it, and it just really bugs you. Loads of people who attempt to do localization with Arabic, or who attempt to use Arabic text, shall we say, don't understand this. There's an acquaintance of an acquaintance who writes a blog called Nope, Not Arabic, and the link to that is at the end of the slide. It's basically just screenshots of all of these complete failures of Arabic writing that he sees all around the place. Like, you don't understand. Sometimes they don't get that it's right to left. They never get that the shapes change. And it's illegible to someone, it's basically illegible to someone who's trying to read Arabic, and it's ugly. Luckily for this, you do need Python BID, but there's another library. I think it's actually adapted from one for Android development called Python Arabic Reshaper. And this is super simple to use. Do I have? Nope, that's it. Yep, basically, you can just import it, call a function, and you get this beautiful writing which is actually readable. Just so now you're aware of that, and there's no excuse. I don't want to see any of you on this Nope, Not Arabic blog, okay? Okay, so we keep going. And now we're in East Asia. Well, I mean, we're not yet in East Asia because this is English. Can you spot the difference between these two lines? Yeah, of course you can. One is much narrower than the other. And some fonts don't even bother sort of applying the font to the wider characters, like Korean U. The difference here is that we have half-width characters, that's the line at the bottom, and that's what we're used to here in the West, and full-width characters, the wider ones at the top. And why do we need these? Okay, there's a diagram that I now wish I'd put right after this slide, but we'll get to it in a second. Why do we need these? We need these because they're used in East Asian languages. These ones in particular are used obviously when you need to put English or other Roman texts into a block of East Asian script. And I'm saying East Asian script because there's actually quite a few different scripts going on here, different kinds of characters. These are Han characters. They're used in Chinese, Japanese, and Korean, and they're always full width. So they're squares, essentially. They fill a square block. And these are kana, they're Japanese. And as you can see, there's two different kinds, wide ones and half-width ones. And the quite cool thing about this is that the half-width characters were originally, I think this is true, originally used back in the 80s, in the past, when electronic displays started to become popular. Because you can't really, like on the readout of a cash register or a calculator or something, or in the console, you don't have space for these big kind of leisurely square blocks. So they just made squished versions. Squished versions sounds a bit rude. It's fine, there's no value judgment there. And then finally we have hiragana. This is also used in Japanese. These are used in Japanese, and they're always full width. And there's a bit more to Korean scripts, but we're coming to that in a second. Okay, so they sometimes use half-width characters in Japanese, but more often in all of these countries, they use full width. And it's just so much nicer. I don't have a contrasting image for this, but this is from the W3C commission. This is full width East Asian characters with full width Roman characters. And you can see it more or less forms a block. Everything has the same spacing. It's more restful to read than if every time you needed to put in a Roman character word, it just went like that. Okay. And the upshot of this is that Unicode has this bunch of extra letters that people in the West who don't ever think about this just don't really know exist, except when you go to a Japanese or Chinese website and you see, whoa, they're using this really ugly script for the English stuff. Don't they care about us? This is sort of more on the subject of my career. We're kind of going east across the world and backwards in my career history. When I was straight out of university, I got the job doing data entry for a company that arranged conferences and conventions and stuff for materials science. And a lot of the people they wanted me to get in touch with were at Chinese universities. So I would go onto the main website and see like the splash screen, and it would say, our university is the best, it's all lovely and styled. But as soon as you kind of drill down onto the individual pages for groups and professors, they're writing mostly Chinese for a mostly Chinese audience, and when they have to include Roman script, it's whatever came with their font pack. And most of the time, the people who design these fonts don't really put much effort into making these look pretty to the eyes of someone who speaks English, because it's not their priority. So yeah, whenever you go on an East Asian website and you suddenly see this ugly script, that's the reason why it's there. Okay, but we are localizing our websites or whatever, and we have to handle full width and half width characters. And the really nice thing is I found another open source library, because open source is fantastic, and the Python community making libraries is also pretty fantastic. This is called JAConf, and it handles hiragana, katakana, I think the other scripts I just showed you as well, and Roman letters. And you can see I have my string here, and I can turn it to half width, and then when I have the half width string, I can turn it to full width. And I can do the same with my Roman characters. And the interesting thing here that you might notice is that I start out with Roman characters as my very unimaginative string. And when it goes into full width, it has this U3000 in the middle. That is the Unicode code point for the full width space. And and something I found that I hadn't really been aware of before I prepared this talk, is that there are loads and loads of empty spaces in Unicode. Like, there are loads of different white space characters, most of which I certainly have never needed to use, but it's good to know that they're there in case sometimes it crops up, like, for example, just here. Okay, great. Right, we are now on to my favorite part of the talk. This is the part where I get to absolutely nerd out about Hangul, which is the Korean writing system. And I just love this so much. I just love that it's a thing that exists in the world. Basically, the story is, in the old days in Korea, they used to write in an ideographic script, much like the ones that we just saw for Japanese and Chinese. I think hiragana is ideographic and kana aren't, but you know, the thought is there. And then one day, this guy, and I have his name and the time frame in my notes for this slide, which I can't see. But you know, the king, basically, the Korean king, said, you know, this is nice, it's traditional, it's very pretty, but it's really hard to learn. And it's really, you know, I want my people to be literate. I want everyone to be able to write things down and keep records and be accountants and keep history and all of this. We need to make it easier. So he said to his court, make this better. And they said, okay. And they came up with Hangul, which is a phonetic alphabet and writing system, which is just supremely logical. I was actually reading a couple of papers a week or so ago which argued quite persuasively that dyslexia rates are lower in Korea than they are in Europe because it's easier to tell the different letters apart, the different characters in Korea. And so, you know, if you have a mild dyslexia, probably you won't have a problem where you might if you were starting to learn as a child how to write in English or German, say. And I've also given you a link here, like I did with Turkish, to a page that has a lot more details on this. But basically, the main idea behind Hangul is that it's there are different characters for the consonants and for the vowels, and you write them grouped together in bunches of 2 or 3. So for example, as you can possibly guess, up here is the Korean way to write Hangul. And you see we have the sound h, the sound a, and the sound n, and that's 3 characters which are generally written to make 1 syllable. And then you have, on the other side, g, and u, and again they're written together. And from a relatively small, like a few dozen, different sound characters, you can make 10,000 different syllables, and it's very legible and readable. Okay, so that's Korean, and you should learn Korean and learn to write 5? 15, thank you. Okay, yes. You should learn to read and speak Korean and go to Korea and eat Korean food. I mean, you don't have to, but if you want to, that would be great, and I encourage you. But for the meantime, we're still making our international website. And we have to deal with Korean characters now. And like I say, this on the left stands for Han, and then on the right it also stands for Han. You can theoretically write the characters separately like this in Korean, but you wouldn't really do it. It looks weird, it's harder to read because you've got used to reading the syllables. Maybe if you really wanted to show someone how something was spelt. And this is going to demonstrate quite a nice thing about Unicode as well. Here we see canonical equivalence. We are using Unicode, of course, to create these characters, and we have 2 ways of writing the same thing that mean the same to a human. Unicode knows about this. And we have 2 different forms. They have 2 different names. Normal code D is the kind of exploded way, and normal form C is the composed way. And then there's another kind of equivalence in Unicode as well. This is compatibility equivalence. And that means sometimes because of the historical ways Unicode got built up over the years, you have two identical characters that have different code points. And the easiest example is the one I've got up here on the screen. Obviously, if you're writing in Roman numerals, actually quite relevant since we're in Italy, 1 is an I, and it's the same character, it looks the same, but it actually also has two different Unicode points. And so this is compatibility equivalence. And, okay, say, for whatever reason, I need to switch between these two different kinds of Unicode equivalence. Actually here, Python 3 has this covered. You import Unicode data, and it has a method normalize, and you can just say, I want the normal form D, I want the normal form C, here is my character. And again, I have, because it's a nice recognizable example, I have the word Hangul. And you see, if I tell Unicode data to normalize this to the normal form D, decomposed, it decomposes it for us, beautiful. And then say, I tell it, well, you know, I have all my different characters, and I want you to compose this so that they are arranged in the correct way for a human reader of Korean. I want you to give me the composed form and give it to Unicode data. Very easy. We have now normalized in the composed form our Korean characters. Okay, so in both of these cases, I've been looping over all of the characters. But as you can probably see, can I go back here? Oh. The buttons aren't working for some reason, so I'm just kind of doing it with the mouse. Yeah, we started out with a string, like an actual word made of different syllables. So what if I just take that and I don't bother to go over the characters? I just say, here's my string, normalize it. And if you're doing this on the console, and if you're using the same console as me, because I have a feeling it may be different in different operating systems, you get this, which is not what we expected at all. Look at this. It's nonsense. It's like I take one word, and then I take the other word, and then I just kind of mesh them together. And I think what's going on here is that so Python is giving the console the two different characters in their decomposed form here, normal form D. And the console knows, hey, this is two characters. Okay, so each of one of them gets like the width of a character, which just means they kind of overlap because, of course, the actual width of 3 characters is 3 characters. The good news is Python actually knows what it's doing here. When I saved this to a new file, I got out what I expected to see. But some consoles and probably loads of other things, loads of other display systems just have no clue because it doesn't come up, or because they can't be bothered to fix it for a Korean audience, or whatever. Okay, so far I've talked about displaying mostly. And now we come to security. And of course, I'm going to tell you everything in the next sort of 5 minutes or so. 10 minutes, I have 10 minutes to tell you everything about the security implications of Unicode and different writing systems. Are you ready? Yeah, we're not going to do that. Security is a massive topic, and 10 minutes in a PyCon Italia talk is not really enough time to tell you everything about it. So I'm just going to give you a couple of my favorite examples of why this is an important consideration, and kind of give you some things to be aware of, like some tripping up spots where you might create an issue. Okay, so the first thing is SQL injection. And the good news here is if you're using a proper ORM, then this should be mostly taken care of. Like, do check. But if you're using modern systems, you probably don't have to worry about this too much. But it is a concern. And just in case there are any kind of newish programmers who don't really understand or who haven't considered this yet, I'm going to go through my example. So I have a website, and my website accepts user text. And my user wants to tell the world, I don't like raisins. They're wrong here, but the main issue in this is not the user, it's me for building a bad system, which you'll see in a second. Okay, and to type this, obviously they use an apostrophe. And when I'm about to put this information into my database, I have to sanitize it, which means I need to tell it this apostrophe is not the end of a string, it's just a character in the string. And I do that by putting a backslash in front of it. Because otherwise, later on, this string could be served back up to the front end, and yeah, it would be very confused. I have this string, then I have this other stuff, which possibly is a command. Who knows? Just gonna kind of give it all back, deal with it, website. Okay, so it's fine, we're sanitizing. We put in a backslash. And the hex encoding of the backslash, it's 1 byte, that's 0x5c. And now I'm going to introduce the next character in this little story, which is this character. I did know at one point what this character meant. I think it's in my notes. I do not know it now. It's just a useful Chinese character. And because it's sort of further up in the ordering of Unicode, it takes 2 bytes to encode the code point of this. And say you're using UTF-8, strings that, code points that can be encoded with 1 byte get 1 byte, like the slash. Code points that have to be encoded with 2 or more bytes just get 2 or more bytes. So we have 0xb8, 0x5c. And say my user, instead of telling the world I don't like raisins, just instead told me 0xb8, and then an apostrophe, and then or 1 equals 1. Now, when this goes through and gets put into the database, we sanitize it nicely. We stick a backslash in front of the apostrophe. Unfortunately, when this comes out, what this actually means is we're telling it Chinese character or 1 equals 1. Yes. And so, yeah. So my user types this into the website. The ORM or my front-end code or whatever sanitizes it nicely. Then we pass it into the database. And the database, for example, is saying search for all telephone numbers where name equals Chinese character, or where 1 equals 1. Of course, 1 equals 1 is always true, so it just kind of spits back out all of the telephone numbers in my database, and the user says, gosh, well, that's interesting. I can do something with these. We don't want them to do something with those. Okay. So the moral of this story really is just use a modern ORM, check that they take this into account, and that you're not going to get hit with it. But generally these days, it should be looked after for you. On the other hand, this is a security flaw. Oh wait, sorry. This is a bit more information with on the topic I just told you about. This, on the other hand, is a security hole that came up last summer when I was first starting to think about preparing this talk. And I just got so excited. I was running around, has anyone told you about the address bar spoofing? It works in Firefox, it works in Chrome. All of my friends are like, 3 in the morning, Ray, please don't call me. How did you get my number? Well, there's this thing you can do with SQL. But basically, by the time I found out about this, it had already been fixed. I was in I was in a talk actually earlier by Lily, who was talking about what to do in case you find a security hole in someone else's system. And the correct answer is tell the developers. And in this case, someone had discovered this flaw and told the developers, and by the time any of it came out, it had been patched. But for a little while, it affected both Chrome and Firefox. And here's how it works. We have at the top this awesome google.com link. And you can see, obviously, HTTP, google.com/test, blah, blah. Roman characters go left to right, we know this. And on the other hand, at the end of the URL, we have some Arabic text. It goes right to left. And we know about logical ordering. So, we give the characters are dealt with by all of our programs in the logical fashion. So this piece of text would be processed right to left. But what you can possibly see here, which is white and not yellow, just to sort of highlight it, is this slash. And the slash is a character that's sort of, it's not left to right, it's not right to left, it works in either. It's kind of a strong character. And the bug that was happening for a while in these browsers was that you could put in something like this, and when it was passed, like you could type it in, when it was put into the browser would consider it, and it would see, okay, right to left, strong character, left to right. Okay, so that means, it would get fixated on this strong character and consider, right, now here we have to flip. It's right to left, like we start out left to right, then we have this character, then right to left. Oh, but that means the right to left takes precedent. And so in fact, you would be going to, this sort of really mostly works because the HTTP / is implicit in most browsers. Like you don't see it if it's there, you don't have to type it. And so we would be going to this Arabic URL / google.com test. And who knows what's there? Probably some nest of people who want to steal all of your data because it's a hack. That's kind of what it's for. And here's an article which explains the full details of how this happens. I think the guy who wrote this article is actually the one who discovered it. And alerted people to it. Okay, so that's it for security. That was really just a toe in the water. What I want you to get away from this talk is this stuff is not easy. There are little slip-ups, little kind of points where you can catch yourself that would never really occur to you. Because I don't know about you, but, well, you know about me already. You know I speak English and German, but I don't speak Korean, I don't speak Turkish, Hebrew, or Arabic. So if I have to deal with this text, I'm probably just going to mess up somewhere. But on the other hand, it's really interesting. This is what you get when tens of thousands of years of human culture all over the world kind of collides with electronic systems trying to standardize everything. And sort of put it into neat boxes so computers can use it. And yeah, apart from that, what I want you to remember is you will never be the first person to have your particular problem with Unicode. There will always be someone who's been there before you, found it out, and has probably made a library for you to deal with it because Python is wonderful. And yeah, my final point is if you haven't already started using Python 3, I really hope you will start because it's great. Thank you.
Hey, if anyone has questions? Hi.
What about language like Tamil that merges letters and mounts other parts of letters inside, but you have different direction and more than 247 letters, if I'm not wrong with Tamil. They are handled correctly in Python 3. Mm-hmm. And about the dotless I, I think it was fixed after Python 3.4. maybe. It was a bug in the earlier version of 3 and is still in Python 2, but I think 3.5 fixed it.
Okay.
What I don't know is it a problem of Python or the C-locale libraries beneath Python?
It is a problem with the C-locale libraries beneath Python. And actually, when I was sort of researching this, I kept coming upon bug reports, 2015, 2012, 2009, all of these people saying, hey, I tried to do Turkish and .i is broken. And someone saying, yeah, it's been a problem for a while, we're going to fix that. So it's really good news. Thank you a lot for telling me that it's fixed in 3.5. As far as Tamil goes and other languages with characteristic you described, I actually don't know much about them. I should research them. I should, figure this out, actually, so I can answer this question in future. But I will just say, this is my links page at the end of the talk, and one of these links, the second from the bottom, I can text you a pile of poo, but I can't write my name. Actually deals with the problems of someone whose native language is, I don't remember exactly, but it's one of the Indian languages. And his problem is that there are characters that he needs to write in his name, for example, which don't have their own Unicode code points. They can only be composed. And so if you're writing on a keyboard, this means quite a lot of juggling, but at the same time we have all of these Unicode, all of these emoji, and they have their own code points, and went in with no trouble. So there's a lot of politics involved in Unicode, like linguistic and national politics, which I haven't touched on at all. But yeah, thank you for bringing that up. Thank you.